I will never forget the first moment that I saw those little tiny squares that you see on the screen. I didn't know what they mean, but I had something that tells me they're talking to me and trying to say something that I haven't really understood at that time. Later on, I discovered that those tiny squares are the genomic blueprint for more than 2 trillion of our T and B cells. The cells that defend our bodies from bacteria and viruses, such as COVID-19. And I start wondering, what would happen if we were able to identify those genes within the genome of everybody? Oh, this is a big, big breakthrough. It's like something we haven't seen before. But what I can say, it's like, you know what? It's like identifying everybody's genomes and identifying the cells that normally do our jobs in our bodies. So identifying those genes will allow us to do a personalized treatment and personalized, precise treatment. Identifying those genes is named annotation. And it is a very challenging task. It requires time, money, and skills. Imagine a single annotation can last several months and requires a dedicated team who will try to locate those tiny genes with the millions of DNA sequences. It's like finding a needle in a haystack. In my thesis, I'm on the verge of making automatic annotation of those genes possible, thanks to artificial intelligence, big data, and computational science. With a single click on your mouse, my technology is able to identify those genes at the speed of light. This technology works like a little brain that contains billions of artificial neural networks. Those neural networks are able to analyze billions of DNA sequences. Like I say, this technology is a breakthrough. It will allow us to decipher everybody's immune systems, adaptive immune systems, which means that we can have a personalized treatment based on our genomes. That is to say, we can have the right treatment for the right person at the right moment based on all those genes that we found with automatic annotation.